hear our presentation. Okay, today we are going to present about the distillation process. So firstly, I will introduce to my awesome and my friends. Alice, Ida, Wali, Christine, Dashini, Penny, Zakwan, and two of my members cannot make it because they are already at their hometown. Who are they? Malini and Neshu. Malini and Okay, our content presentation will consist of first distillation, steam distillation, distillation, start distillation, and our group will try to explain one of the biggest application in distillation, that is for water projection manufacturing. So I will give the first slide for introduction part to Rahman.
Good morning everyone. Assalamualaikum to my Muslim friends. Today, my part is introduction to distillation. First thing, what is distillation? You all know that distillation is the process where we want to separating the liquid mixture from what substance that we want. For example, you got salt solution mixture. That salt solution mixture maybe contain water molecule and sodium chloride powder. But how you want to separate it? You know how we have to use the process to separate it? I will explain it. I will explain to you now. The process is very simple. You can use many methods. One example is in our daily life. In ancient times, we use sun as our source of heat to heat up the liquid mixture that contain liquid that have water molecule. For example, water molecule and salt. I will write down the salt as X. If you confuse it, X is sodium chloride molecule, and brown is the H2O molecule. Okay. During this time, the evaporation will take place, whereby the water molecule will evaporate at any temperature. Must know that. If you leave it for maybe 1 or 2 days, the beaker will only contain a certain amount of water, but a lot of sodium chloride molecule. But if you leave it more, maybe 1 week, you only will contain the sodium chloride.
Form or crystal.
Powder, sodium or crystal, like Mr. Shami said. This is through evaporation process. Okay. But must remember that we want to do distillation, we not only want the water molecule substance or water liquid, we also want the sodium chloride. But in this process, we already lost the water liquid. Okay. Through the distillation, now we go to the part where distillation occurs. Okay, distillation it involves maybe around 2 principles or 2 processes, whereby the evaporation takes place and the condensation process also takes place simultaneously to obtain the liquid and the salt at the same time. For example, we use the same example as this sodium chloride solution. For example, how we want to separate both of them in the same time. We use maybe one molecule, something like this material. Then we put the sodium chloride solution or mixture that contain water and sodium chloride. Then we must put the apparatus to set up the condensation process. Where maybe we will put maybe some here we will put stopper and then cooling system. Okay, listen guys. Just give me 3 minutes more to explain the distillation process. 3 minutes more. Okay guys. Okay, during distillation process, what we need is heat to ensure that the water vapor will evaporate at this side. What sort of heat we have in the lab? We got Bunsen burner. Maybe if you want to use Bunsen burner, it maybe take a short time to use Bunsen burner than lighter or matches. Then, if you apply heat at the bottom of the liquid mixture that contains sodium chloride solution, the water molecule will evaporate faster if you heat up it until 100 degrees Celsius, whereby the water liquid will evaporate, at which the boiling point of the water temperature is boiling point. Then the water will evaporate, but it doesn't go anywhere, but inside the condenser. What happens at the cooler is, when the water vapor pass through this cooler, it will make its way inside the water cooler or the cooler. Inside this water cooler, the condensation process will occur. Inside the cooler, the condensation process will occur, whereby the water will dance into the tube and form a water liquid if we got water in and water out to make the water produced inside this beaker more efficiently or more effective or more. If you put something in between 500 ml of water plus 10 grams of salt, maybe if you use this cooler, maybe get around 495. Maybe some of them will evaporate. You cannot expecting it. Maybe it is in nature to evaporate. Not all cooler is effective enough to condense the water. But if you got coolers that have a low temperature, it will make the water vapor to condense and flow inside the beaker, and you can collect it. If you want to drink, you can drink it. But it's safe to drink. It does not contain any contamination, because during the process, if you got any, what we call it, other particles or dust or impurities like fluxes, right? You can avoid from drinking these impurities. Also act as disinfectant. Okay, I take more than 3 minutes, sorry guys. That's all about the distillation process. The condensation process occurs at this point, where the water vapor will condense into water liquid, and the evaporation process occurs at this side. And that's all about that. And that's all about the introduction. And the application of the distillation, you can see there is in industrial distillation and distillation of fruit and perfume, food processing. That's all my friend will explain it later. But we got many different types of distillation in this time. For example, simple distillation. Okay, simple distillation and other one. Maybe my friend want me to go faster. Maybe my friend will explain it to you about all of distillation. Thank you guys.
Thank you.
Hi everyone. Now I will present about simple distillation. Simple distillation is a process of separating two different liquids that have different boiling points. But the difference of these two boiling points should have at least 50 degrees in difference. The system applies condensation principle. The liquid will be converted into vapors, and then it will turn into, and then it will reform back into liquid. Okay, basically, this is the apparatus setup for the simple distillation. And actually, Abdurrahman already mentioned about the mechanism. In simple distillation, we have head source, distillation flask, condenser, and the receiver. As the distilled liquid is being heated, the liquid that has a lower boiling point will boil first, and then you will convert it into the vapor, and then the vapor will flow down in the condenser, and then we will collect it in the receiver. The functions of the condenser is to convert the boiling vapors into liquid. And then why there should be water inlet and water outlet is to provide and maintain a cooling environment.
Thank you.
For the application, simple distillation is applied in laboratory distillation, vegetable distillation, distillation of herbs for perfumery and medicinal purposes, and distillation in food processing. For the advantages, the simple distillation removes bacteria and viruses, so it is used worldwide, and it provides faster distillation times and prevent waterborne disease such as typhoid fever and salmonellosis. The disadvantages is it requires the liquid to have a large boiling point differences, which is the more than 70 degrees Celsius. And but the disadvantages is it gives poorer separation than fractional distillation. And it makes water become acidic because when the substrate is removed, the hydrogen become greater in proportion and causing the water become acidic. Long term of consumption of the distillation water causing mineral deficiencies and harm the body system.
Good morning everyone. I'll be myself and Christine will be talking about fractional distillation. Fractional distillation will be, you can define it as a process of which saturation of mixture of various components by using their boiling points by heating to a temperature where they will be easily evaporated and formed at different fractions. This is usually for more to volatile mixtures, and the principle is usually they use based on different boiling points between the mixtures of two substances. It could be two or more substances, but it doesn't matter. So it depends on what it is. For example, you can take as distillation of mixture and ethanol. First, if for example the mechanism, we can talk like how to say it will be fitted like this. They will assemble the apparatus exactly like this. First, what they will do, they put the mixture into the round bottom flask here, and then they will put the fractional column at the top with the condenser at the side. Then as the condenser comes, they put the temperature, the thermometer to make sure that the temperature they need to heat the mixture is at a suitable suitable temperature or optimal temperature. So when that happens, as the distance is where they will heat from the water. They cannot heat directly because they usually use volatile mixtures which are usually flammable. So when they are flammable, direct heating can cause it to flame burn up very fast or something. So first, the mixture is put into a round bottom flask along with fuel anti-bumping granules, and the fractionating column is fitted at the top. The fractional distillation column is set up with heat source at the bottom, as shown in the diagram, and it should be under the, of course, it should be under the bottom flask, and the vapor condenses, or when it heats, it will condense, of course, and it will go through this the fractionating column, and it will go through this condenser and it will start to condense in it. As it condenses, the mixture of one of the mixtures will be separated and it will go to the collecting container. So it will be there. That's how the fractional distillation works. So this is the mechanism. So as I said just now, first you heat the mixture of two or more substances. The mixture will begin with boil, vaporizing some of the substances. Of course, you cannot get the full substances, just like how Rahman was doing here. You put 500 ml, you will not get 500 ml, you get less than that usually. That's how it usually works. And vapor goes to the fractional distillation column, or the long tube, where just now you saw it's a long tube. Then the vapor rises to the top and begins to cool down on its way down to the second column, which is where the condenser goes to. And the condenser is the one that cools down the vapor and changes the vapor to liquid form. So it's a condensation process. And finally, the substance is transferred into a container. And on the other end of the second distillation column. So that means the end just now you saw, that's where the final substance will be collected. Yeah, that's all from me. The next will be
So, I'm going to learn about the application, the advantages and disadvantages. So, first of all, this is the application. There's two primary applications of fractional distillation. First of all, it's used in the refining of crude oil, and second of all, it's used in the manufacturing of alcoholic beverages. So, in the refining of crude oil, what happens is crude oil contains many substances with different. Crude oil contains many different hydrocarbon molecules. So because it has different hydrocarbon molecules, it has different boiling points. So what will happen is during fractional distillation, these chemicals will be separated by their boiling points. Those which have lower boiling point fraction will rise up to the top column, for example petroleum, and those with higher boiling point fraction will fall to the bottom of the column, for example paraffin gas. And then there will be some that will be in the middle, which is also known as intermediate boiling fraction, for example fuel, diesel and kerosene. Then in the manufacturing of alcoholic beverages, so example of manufacturing of alcoholic beverages is in the production of whiskey. To make whiskey, barley will be soaked in water, and after a series of process, it will form a sugar solution. These will be added to this solution, and fermentation will occur, thus producing ethanol. So, what will happen is the ethanol will be distilled twice in a copper fractional distillation vessel called still, and this will then produce a concentrated ethanol solution. This concentrated ethanol solution is what will then be your whiskey later on. Okay. Then next is the advantages. The advantages of fractional distillation is, first of all, it has high efficiency, which is why it is used in the refining, used in oil refining, because it produces a maximum yield. Second of all, it's easy to use.
Thus, it will minimize the time needed to operate the equipment. And last is it has better separation between liquids compared to the special distillation. The disadvantages is it is expensive. By the initial fractional distillation, it's expensive, and also to change the components is expensive. Second of all is operational risk. So in the process of distillation, it usually involves high pressure and high temperature. So there's always a chance for explosion to occur. And the last one is environmental factors. So fractional distillation uses a lot of energy. Besides that, as we said earlier, because it involves high temperature and high pressure, and explosion can occur. When explosion occurs, it can affect the surrounding environment. That's all from me.
Morning all. Me and Ashley will be explaining about the steam distillations, and I will be focusing more about its principle and its mechanism, whereas my partner will be focusing more on its application, advantages and disadvantages. Steam distillation is very different from the other distillation methods because it is only applicable to use in the liquids which are not soluble in each other, or in other words, immiscible. Generally, as we all know that when the liquid substances is heated, it will exert its own vapor pressure. And then when this vapor pressure is equal to the external atmospheric pressure by increasing the temperature, and then the liquid will start to boil. In steam distillation, there will be two liquid mixtures or more than that, and then each liquid will exert its own vapor pressure. By the summations of the total vapor pressure from the vapor pressure of water and the vapor pressure of oil, for example, will make the external atmospheric pressure achieve much more faster and therefore at a lower temperature. Therefore, in steam distillation, the temperature recorded for the boiling point recorded for the liquid mixtures will be much lower than its normal boiling point, because there is two liquid substances which exert their vapor pressure altogether. At the end of the distillation, there will be two liquid phases selected, and then because of the two phases of liquid, it makes the separations of the liquids become easier, so you can collect the things that you really want to collect, or we call it as distillate. This is the experimental setup for steam distillation. The boiling flask is filled with the liquid mixtures and including the things you want to get at the end. And then the separatory funnel is filled with water, and the water drips or drains into the boiling flask in order to provide a reasonable mixtures of water, volatile components, and non-volatile components. And then the second, the boiling flask will be heated, the vapor rise up, and then the vapor rise up when the boiling point is achieved. And then at the same time, the volatile oil is carried by the cooling water vapor down to the condenser, and then will be collected in the receiving flask. As I mentioned before, at the end of the distillation phase in the receiving flask, you will be having two phases of liquid, and then from there you can get the things you want.
Good morning everyone. I'll be explaining about the application of the steam distillation. So as said by my friend before, the steam distillation is specially used for the distillation of two immiscible liquids. So it also can be used to produce essential oil distillation such as perfume, lavender oil, tea tree oil. So the example that I'm going to use today is actually spanning alanine extraction. So as said by my friend, is the mixture of organic compound here. So the alanine will be impurities. So it will be steam will be absorbed into this solution and will produce vapor pressure, and it will move to the condensation, which is the temperature. So the steam, the extraction will be condensed into liquid state, and it will be transferred to the receiver to get the liquid extraction. So since this mixture of inorganic compound containing alanine and water steam is introduced and the mixture was evaporated into the steam, and the steam is then passed through the cooling system to undergo condensation, and the extraction is collected in the flask. Okay, next I'll be explaining about the advantages. Okay, there are several advantages of using this steam distillation. So normally if you use simple distillation, it can produce a high boiling temperature, and it may cause degradation of certain substances which has heat sensitive materials. So heat sensitive materials can be easily degraded if we use high boiling temperature. So the suitable method to use for the heat sensitive materials is steam distillation. So by adding water molecules to the immiscible liquid, we lower down the temperature boiling point, and thus it can prevent the degradation process. So such that also consume less usage of fuel for steam boiler. And disadvantage is it will require high cost of investment for this equipment to execute the process successfully, and there will be some initial training have to be learned, certain condition, in order to operate the equipment. Normal person cannot easily can maintain this steam distillation, so you need to undergo some training to execute, to handle this equipment.
Okay guys, so next is vacuum distillation. So before I proceed, what is vacuum? Vacuum is actually a region where the gases pressure is actually lower than the atmospheric pressure. So this is the principles of vacuum distillation actually. They got the name from that. Okay, this is the principles of vacuum distillation. Okay, liquid will boil at lower temperature. As we know, if we decrease the pressure of a certain liquid, we can increase the boiling point of the liquid. So vacuum distillation is actually used for substance compounds that have higher boiling point, that they tend to decompose at their atmospheric pressure and also at their boiling point. So boiling under pressure makes rate of distillation increase. Like I said before, as we lower down the pressure, we can increase the boiling point of certain compounds. And unstable liquid at their boiling points at atmospheric pressure may be distilled at a much lower temperature under reduced pressure. Okay, next, the mechanism. There are not much difference for all distillation process actually. And this one, simple vacuum distillation, use only basic apparatus, and for glycine vacuum distillation, we use a different flask for that experiment. The mechanism is just not the same with all of other mechanism of distillation.
First, I want to focus on the distillation aspect. First, we're using the vacuum distillation. As we all know that we can boil some substance under the boiling point. So this is quite important. Firstly, in the processing of vitamin A, E, and K concentrate. For example, that you want to boil fish oil and you want to extract all the vitamins, essential vitamins, and the one to mix with other substance. So we need this type of vacuum distillation. And for second is a lanolin fractionation. Lanolin is, as we all know, is a if I'm not mistaken, is a sheep oil. Fat oil. So lanolin itself contains very many particles and composition. So by doing this fractionation, we can get a more pure substance from the lanolin oil.
It is called the wool fat. Wool fat. The sheep wool fat. So it is smelly.
And then the oil fractionation. This essentially oil fractionation, as we all see in the industrial actually is composed using the two principles. First is fractional distillation, and second is vacuum distillation. Why we use vacuum distillation? We need to speed up the process, and then we need to reduce the energy consumption. And then for the heat separation or polyethylene glycol separation. Okay,
Okay guys, so next application and advantages and disadvantages of vacuum distillation. Before I explain the one about the applications of vacuum distillation in pharmaceutical industry. Okay, I'm going to explain applications of vacuum distillation in other aspects. Petroleum refining, metal refining, alcohol distillation and dehydration process. Petroleum refining commonly we can use in order to produce petroleum. Normally crude oil will contain a lot of hydrocarbons, so we are going to use vacuum distillation in order to distillate and get the hydrocarbons. Vacuum distillation is not the only distillation process used for petroleum refining. We can also use simple distillation, atmospheric distillation and also vacuum distillation. Okay, for metal refining, actually we can use either liquid separation process or combination of distillation with radioisotopes. This is in order to get the radiochemical substances extract from the compound. Alcohol distillation, we can use this in order to make perfume. And dehydration process, dehydration process is actually the basic principle of the vacuum distillation. And also, actually the other application of vacuum distillation, we can use it in order to reuse the industrial wastewater. Okay, the advantages and also disadvantages of vacuum distillation. Can be operated at lower temperature? Yes, because we want to get the lower pressure in order to make sure that vacuum distillation is at the best. Okay, more economical in separating high boiling pressure compound. Because basically we're going to use high boiling compound that tend to decompose in vacuum distillation. Avoid degradation of some properties. Yes, because at the atmospheric pressure and also at high temperature, some compounds will degrade, faster processing time and effective processing of high boiling point solvents. The disadvantages: high energy cost, uneconomical in commercial appliances. That's why we are not going to use vacuum distillation in other certain commercial appliances. High operation and installation cost, large column diameters needed, because like I said before, in in vacuum distillation, in petroleum refining, we can use another type of distillation, either atmospheric, vacuum, simple. So actually there are a lot of columns that we need to use in order to refine petroleum, and also pressure and energy leaks due to any leaks or cracks. Okay, that's all. Thank you guys.
Seems bombastic, sound like distillation, right? Actually, destructive distillation is the distillation. Usually, that you see distillation uses wet or liquid, but in destructive distillation we use solid materials. Actually, for destructive we only use two main substances or two main things, that is only coal and wood. Because from coal and wood only we can get many substances that can be used in our daily life and our pharmaceutical composition. But this product of distillation have a very good smell. Okay, this is the apparatus. After this I will show you short YouTube video about how we can perform the destructive distillation of the microphone and the distillation. It has many applications, but I want to focus on the coal tar. Okay, as we all know that first we can put a very simple coal powder and then we heat it until certain temperature, and then it will produce three main things actually. First is the main substance, that is coal tar, and then some water, and then in this water also they have some gases like ammonia, and then the coal gas. The coal gas is very flammable, but one of the most important substances that was arrested is the coal tar, because coal tar is one of the most purest quality of coal that used to make activated charcoal. You cannot take a simple charcoal that you can buy at the shops and you make activated charcoal. Please no. because this is a very sterilized and high purity of charcoal used in draft manufacturing and also and so on. And ammonia is used for fertilizers, and actually this type of distillation is already done since the World War II, and it also have a very good industrial thing because it manufactures many things that can produce. And then for wood also can produce methanol and also charcoal. Is very energy efficient because we don't need to generate a high volume of heat to produce this because it's just a cold powder and then you heat it and it will produce the desired product. And then the available chemically for the same produce. But the advantages is they also require high temperature for this distillation. Actually, this is for the industrial purposes. And to obtain volume, this type of distillation that we carry out industrial because as I say that for simple we can just take a small portion, but in industrial we can take a bigger portion. And only the water will composition of the product. And the dry distillation only can be carried out in the absence of air. So that we must use a very tightly capped distillation to produce the best product. Okay, we'll proceed with what?
Yes, Assalamualaikum. Good morning to all my friends here. So today I will explain on water fluoridations. It's a major application for distillation process. So first of all, water fluoridation is a purified water by the distillation of by the distillation for the preparation of the product used for the medical use. So it should be clean, odorless and tasteless, and most important thing must be free from the pyrogens. So first step for producing water fluoridation in vapor compression method. The first step, distillation process will begin in the boiling chambers. Okay, the first step, distillation process will begin in the boiling chambers. So the heating element will be turned on and it will boil the water until it reaches the boiling temperature. So when the water boils until it reaches boiling temperature, we will form steam. The steam will enter the vapor system. The steam will enter the vapor system and enter the compressor, which is turned on once the water is reached boiling point. So once the water reaches boiling point, the steam bodies will enter the compressor, and in the compressor the steam will be pressurized. The steam will be pressurized in step 4. And then the steam will enter the heat exchanger and will give up its latent heat of vaporization to the water inside the boiling chamber. So when it gives out the latent heat of the vaporization, so the heat will be transferred into the boiling water, into the water in the boiling chambers, and the water will be reboiled, and the step will be repeated over and over again to produce more steam. So the more steam will be enter the vapor system, enter the compressor, and will enter the heat exchanger again. So the steam, once the give out its latent heat of vaporization, it will be condensed and becomes distilled water. So the distilled water will be sterilized to be free from pyrogens to be used for water fluoridations. So as a conclusion, distillation is the process of heating liquid until it boils, then condensing and collecting the resultant hot vapors. Distillation is used to purify a compound by separating it from a non-volatile or less volatile material. When different compounds in the mixture have different boiling point, they separate into individual components when the mixture is carefully distilled. So distillation can be divided into simple distillation, fractional distillation, steam distillation, and vacuum distillation. With each one carry different types of substances that can be distilled. Thus, we can choose which process of distillation suit the most in order to carry out some particular distillation process.
Then they can come.
You know how it was to get they cannot walk.